speaking on the topic of vehicle grid integration. Ted Bohn from Argonne National Laboratory. Whenever you're ready, Ted.
Okay, thank you very much, and thanks for your patience, everybody, on that long delay as I was just writing the text box. Sometimes it's annoying when it's too quiet. Often we can't have enough quiet. So halfway in between is my presentation. Today I'm going to talk about the Grid Modernization Lab Consortium, specifically interconnection and interoperability standards with emphasis on EV charging and, as the previous slide said, vehicle grid integration. So one thing I wanted to state the obvious, that even though it's a transmission webinar, I'm going to be talking about vehicle loads that indirectly impact transmission but directly are connected to grid edge and distribution systems. And so at Argonne National Lab, as Rob was referring to, there are other researchers who study generation and transmission. I do not. So I work on distribution and research on electric vehicles and integration of renewables. So the next slides are about the Grid Modernization Lab Consortium, that there's, again, along with Rob and the other national labs participated in this, and we have an emphasis on electric vehicle impacts and mitigation through distribution and transmission. So I apologize for the top of the slide being cut off, or at least on my view. The GMLC on charging loads, the Grid Modernization Lab Consortium, for those who aren't familiar with it, was launched in 2015. They put a whole bunch of lab calls out to see who wanted to work on which projects, and the project awards were given out in 2016. And then fast forward to 2018 is where we're at on working on these projects. And again, the partners are utilities and state energy agencies working together with the national labs on these projects. More details are on links to the Grid Modernization website itself. There are 6 technical areas that were covered in that: the planning tools, the device integrated systems, which I'm going to talk about, institutional support, again, tools and data, security and resiliency, which is pretty obvious, sensing and measurement, again, also self-descriptive, and then systems operation and power flow and control. So again, mainly what we're talking about today, but my area is on device and integrated systems testing. So I work specifically on 2 areas, again, just to be clear about what part of GMLC I'm going to be talking about. Is the 1.2.2 is interoperability, which basically is a framework. Here it is. So it has objectives to establish a strategic vision. So what is interoperability? And that's most important. Most people start working on projects before they define what the topic actually means. And many weeks were spent trying to define what interoperability means, how you can assure it, how you can assess it. And again, measuring that state of interoperability is the main takeaway from this. Is in these technical domains, finding gaps and working on roadmaps to ensure interoperability along with industry engagement. So engagement is probably another key takeaway from this project, is to make sure that industry is involved with defining and assessing interoperability of these different systems, both on the transmission and distribution side. The GMLC 1.4.1 works on standards and test procedures for interconnection and interoperability. So again, a variation of that is, how do you know that your system is interoperable and you have adequate interconnection of your resources? And specifically, for instance, the system domains, where are the edges and how are they supposed to interact with other systems? So again, to ensure and assess interoperability, looking at gaps in standards. And then my portion of that is to work on standards and test procedures for real-world vehicle grid experiments. So I work a lot with physical hardware and people in the industry who are implementing these things, not just talking about requirements, so iterating the requirements. And so I'm the head of the Interoperability Standards Committee for SAE on vehicle and charging station interoperability. So I have a lot of direct input on these standards. So the CPUC, the California Public Utilities Commission, along with the other state agencies, are developing policies. And again, it's very important that policy lead implementation, and that if everybody uses the same measuring stick to align the vehicle charging needs with the needs of the grid. And this part that's bolded here is the most important part on the two-way communication. So that doesn't happen right now. So that's a takeaway from this line, is to say, right now, vehicles don't talk to the grid. The charging stations don't always need to talk to the grid because they don't get rewarded for it. But in the future, and again, part of this SB 454 was the Electric Vehicle Charging Open Access Act that said every charge station should be able to openly access information and exchange energy flow and regulation information with the utilities, and hence the vehicle grid integration label. The two key platforms that most of the utilities and vehicle manufacturers are working towards are the Smart Energy Profile and the ISO 15118 protocol. The 15118 protocol mainly deals with the communication between the charging station and the vehicle, and it leaves it very open-ended on how the information from the charging station gets back to the utilities or other energy services provider or the ESI, the energy services interface. So the higher level connectivity is often layered onto that, such with the Open Charge Point Protocol, which is an open high-level communication that allows information about the condition of the grid, energy availability, the different use cases on demand response, and then including Open ADR. And so like other programs, there are no vehicle-side enforcement tools. So I'll say that twice. There's no stick for the state of California on the vehicle side to say the vehicles have to be able to communicate with the grid. The charging stations, on the other hand, there are. And so the Smart Energy Profile and the 15118, there's no charging stations because there's no vehicles that implement this. There's no vehicles that implement this because there's no charging stations that use it. So you can see how it's kind of caught in between, and the vehicle grid integration activity is setting policy and guidelines such that when there are new public funds used, they can mandate that these communication tools are in place, and then eventually the vehicles will come. So integrated sensing communication, I thought this model is good for grounding the upcoming slides. That on the highest level layer, and then this again an NREL Georgia Tech drawing that many of you have seen, talking about interoperability and that we have to harmonize between these different layers. We have enabling technologies, that we have to have different sensors and communication, and it's an IoT thing, right? So how do we make everything compatible and interoperable with others? And then tools and procedures on assessing that. And so you can see on the top you have the market layer, the system control layer, the communication and information and computational layer, and then again the device layer, which most of us think in, but we're actually tied towards the upper layers on how do we actually drive the dispatch of these lower layers. To that end, and again, just stating the obvious that on the far left we have generation, in the middle we have transmission, distribution, and then we have these end-use devices which circle back towards the meter information getting back to the markets and the grid operators. And on the right, you can just see how the smart building systems have all these different nodes that can work together with each other. And in the world of the smart grid and the smart meter and the smart everything, communicate that back to the DSOs and the RTOs and impact the transmission side. So going back to EV grid integration, it's an enabler for lots of things. And the idea is that the interoperability of the vehicles talking to the grid and vice versa, the dotted lines in the bottom between the charging station and the energy service provider and the charging station and the vehicle, if all these tools and techniques can be used to verify and ensure interoperability, it'll make things a lot easier to integrate it. Technologies, we talk about connector standards, communication standards, measurement standards. So on the left you can see a small meter, and you'll see more of that later on, is if we can put meters in different nodes and have a state weights and measures method of legally dispensing electricity as a fuel, well, that can be a new market for the transmission and distribution people. And again, the legal metrology side of it is very important. 100 years ago, someone had to come up with the first method for measuring an accurate gallon of gasoline. Now we have to measure the equivalent for electrified transportation to have a gallon of electricity, but we don't have gallons of electricity. So at Argonne Lab, we have the EV Smart Grid Interoperability Center on the top, and again, this is very small in your slide, but it's a 2,500 square foot building that has a half a megawatt interchange, and right now it shows one 40 kilowatt PV array on the right. There's a second one that's been installed since then. in the center, you can see something that looks like an old-fashioned fueling island. In fact, this used to be a gas station that was refurbished into an interoperability center. And so on that island are multiple 350 kilowatt charging stations. So we have the ability to have about 1.5 megawatt of EV charging loads, so we can look at impacts on distribution and transmission. So again, Interoperability Center allows us to have a lot of flexibility on integrating real-world 80 kilowatt of PV, on battery storage, on large electric vehicle charging loads. And so in the middle, you see a different building that has areas for wireless charging and a smaller smart energy plaza with a 9 kilowatt array and 50 kilowatt charging station. So lots of different tools and techniques we have at Argonne Lab, again, to support this vehicle grid integration and this international harmonization of standards on interoperability. So basically having one definition across the planet for what interoperability is and what it means for vehicles integrated into the grid, vehicle loads. And so here's another, just again, the idea is that communication and control are really important. And so you have coordination of these networked systems, and they're not all networked. A lot of them have individual volt-var curves built into them, and so they don't have a network, they have a voltage profile. So all these different ways of achieving the same goal have to be interoperable. And that's, again, what this drawing shows, is that you have mechanical systems, electrical systems, some have communication, some don't. Some are open loop and some are closed loop. So getting towards the end of my presentation, what I do in the upper left, you can see a small meter about the size of a matchbox. So that's a 19-channel submeter that fits in the lower right of the picture. You see the gray 200 amp panel that fits into us, and you can see in the lower left a circuit breaker format slot. So the meter fits into a slot along with the other circuit breakers and can manage the whole load center and multiple charging stations, in this case 14 charging stations. And the tool you see to the left, the red box and it look like a wall of speakers, those are actually 6 kilowatt loads, so 16 of them. So I can emulate 16 vehicles with this portable fixture, where we can do real-world experiments to complement, to compare and contrast towards emulated systems and physical systems and modeled systems. So that kind of gray area in between for HIL and component in the loop and software in the loop. And so moving on to the, I think it was my last slide, is kind of a timeline where we started the Interoperability Center. We worked with SAE, IEEE, IEC, NIST on these standards and weights and measures, just all these different complicated ways of describing interoperability and requirements for communication and control, and then implementing them in hardware. And then you can see in the lower right is one of these. Handbook 44 is a requirement, as a guidebook for electric fuel delivery as basically distributing electricity to the fuel. So what you see here is a charging station in the field with a little test box that has a certification on it that allows each meter to have the state weights and measures seal placed onto it. In the upper right, you can see wireless charging. So there's many different ways of dispensing electricity, both conductive, AC, DC, and wireless. And so that's the end of my talk about vehicle grid integration on interoperability standards and some of the technology.